So guys, what I will do today, as I said, I wanted to start chapter 4. I hopefully will start it. I'll introduce what we will do in chapter 4 by maybe in the second half of today's class. I did solve problems from chapter 2 and chapter 3. The recordings are there, but I don't want to solve the same problems, because for the same problems you could see the recordings and how we did it. There are also notes, right? So I'll solve different problems today from chapter 2 and 3. Clearly, it's not possible to solve all of the problems, right? And you hopefully understand that. The idea is to solve as many problems as possible, but hopefully you understand that there will be no chance to solve all of the problems. What do you do? If you find some of those problems more difficult, then yes, there are some problems that are more challenging than some others, but that's okay. It's okay to challenge yourselves. And if you need help, that's why I have office hours. You can always reach out. I'm not going to exclude any problems from the homeworks. I know the homeworks are intense and very, very much, maybe very much for you guys, but that serves for the learning purposes. So you'll have to work a lot, you'll have to do a lot of homeworks. Some of the problems will be more challenging, but again, as I said, even though I won't be able to solve every single problem from the textbook, you can always reach out, you can ask questions in the office hours. Am I clear?
Yes, Professor, I had a question.
Sure.
So the homeworks, you said you're going to extend them. So does that mean that even the first homework that we had for chapter 2 would still be extended to the end of the semester?
The thing is, I already extended all the homeworks, and I don't mind extending homeworks as long as you guys do those homeworks, which means hopefully that you learn. I really don't mind extending homeworks.
Okay, so when you say extending, do you mean like extending for another week, or do you mean like extending in?
I always extend by a week.
Okay, so chapter 2's homework would be due today then?
No, all of the homeworks are due next Tuesday.
Okay.
I said it on Tuesday because on Wednesday we have the exam, and I want you guys to have to have some deadline, right? And then I will again extend it, but I want you to do it like most of the homeworks by the date of the exam.
Okay.
You know the exam is on Wednesday, right?
Yes.
Okay, good. Now, let me, guys, if you have any questions, please stop me and I will try to respond.
I have one question, please.
Okay.
Our analytical question consists from few questions inside the one question. I'm just wondering if exam, like for analytical questions, are going to be same?
Exams are entirely based on the homeworks. I think I said it before.
No, I know, but analytical questions, some of them, they consist from 3 or 5 questions inside the one.
That's okay, you may have 10.
So we can have...
Yes, there will be a lot of questions, but that will be manageable to do in the time that you can get. Given conditional on that you have solved those problems already. There will be no time to, probably you will find it very difficult if you see the exam problems the first time on the exam. Do you see what I mean?
Mm-hmm.
If you have already done it, you'll be fine. Yes.
Can we move from one question to
another question?
Oh,
yes, please ask, but I have to start also, right?
Yeah, it'll be quick. I just want to confirm. So for Wednesday, do we need to sign into class, or we just sign on to Pearson to take the exam?
You just sign in the Pearson. On Wednesday, we don't even meet.
All right, perfect. Just want to make sure. Thank you.
Mm-hmm. So this is, guys, one of the homework problems that you see. Do you see my screen?
Yes.
Yes.
You see one of the problems from your homework.
Yes.
Right. So let me copy that, and then this will be the first problem I'll do today, and then I'll solve some others too. Do you see my blue screen?
No.
No, not yet.
Okay. Now you do, right?
Yes.
So some of you may already have done this, but I'll be quick. Before I said that if, let's say, if y equals, why is my word doing this? I have no idea. Let me close it and open it again, guys. Sometimes my word does not really work well. But it's okay. We'll have enough time, so don't worry about that. I said if y equals a plus bx, where a and b are some constants, and y and x are random variables, then expectation of y equals a plus, sorry, what did I do? Equals a plus b times expectation of x, and variance of y equals b squared times variance of x, right? That is something I already said before. And then you have to use this, right, to solve this problem. Here what they are asking is that here you have z, which is a random variable, and this z equals 1 over square root of 49 is 1 over 7, right? Times square root of 49 is not 1 over 7. Square root of 49 is 7, right? Times y minus 43, right? This is y. The first question they are asking is what is mu of c? But mu of c is another notation for expectation of c, right? Then, okay, what is expectation of c? That's expectation of what is c? C is this whole thing. So 1 over 7 times y minus 43, right? And this equals expectation of 1 over 7 times y minus 1 over 7 times 43, and this equals expectation of 1 over 7 times y minus expectation of 1 over 7 times 43. And okay, and then this is 1 over 7 times expectation of y minus 1 over 7 times 43. This is because 1 over 7 times 43, that is a constant, right? So that's a constant because of z. Expectation of a constant is the same thing, right? So same constant. But what is the expectation of y? Expectation of y is given to us, and it is 43 in this problem. So then multiplying this by 43 minus 1 over 7 times 43, and you eventually get 0, right? And that's what they wanted to show, that it is 0, right? That's how you solve this first part of this problem. And the next problem is, what is the variance of c? Sorry, they're asking what is sigma squared of c, but that's another notation for the variance of c, right? And that's variance of the whole thing. And remember, z is 1 over 7 times y minus 43 times y minus 43. and this is equal to variance of 1 over 7 times phi plus variance of 1 over 7 times minus 43. But this is constant, right? So because of z, it does not have any variation, and therefore variance of a constant is 0, right? Because constant does not have any variation, 0 variation. And you are left with this part, but that part is 1 over 7 squared times variance of phi. But then what is variance of phi? Variance of phi in this problem is given to be 49. So then you are left with 1 over 49 times 49, and that is 1. And that is another thing that you are required to show in this problem, or you are asked to show in this problem, and that's it. So that completes the exercise. Now let me solve some other things. Now from chapter 3. Okay, if you guys have any questions, you can always stop me and we can discuss the questions. So the exam will be based on chapters 2 and 3, right? So you understand that. Also, as you know, I have 2 midterms and I take the best score. So that I think helps you guys to be less, to be more confident, right? So just do your best in both of them.
Professor,
Yes.
on the topic of variance, I had a quick question. So one of the formulas for variance is variance equals expected value of x squared, I think, plus expected value of x, and the whole thing is squared. The expected value is squared. You know what I mean?
This right?
Yes, but the x, isn't the x supposed to be squared in the first one as well?
Yes.
So
this is one of the formulas, that's right.
right. Yeah, I just had a question. How do you acquire the first expected value of x squared?
Guys, I don't derive these formulas, right? There are certain formulas that are already derived. So, I mean, I can derive, but they will take a lot of time.
Oh, okay, got it.
So, but also, you also know that okay, so variance of x also equals expectation of x minus ex squared. This is another formula. Another formula for variance is what? Variance of x is, if you use sum,
Minus mu squared, I think.
xi minus mu of x, so the expectation of x, that is also mu of x, right? So the another notation is mu of x of that square times probability, if you have this population stuff, right? You can either do it probability, or you can just then 1 over n, right? Changes from 1 to n, right? So this is another formula for variance. And then, but none of these are applied here. Here is another thing. They're asking for the variance of this whole thing, but that's a linear function of y. The z here is a random variable, which is a linear function of another random variable y. Why do you think that any of these formulas of variance are useful here?
Oh no, I wasn't asking how they relate. I just wanted to I was like a separate question than this question itself.
Then okay, that's completely fine. Okay, so guys, I want to emphasize, I want just to say something about this course. This course includes a lot of formulas. Do we memorize those? No. I mean, you do over time. For example, I remember some of these formulas because I saw this a lot of times already. Do I need to know? Do I need to memorize all of it? I don't need to memorize any of these formulas because I can see them in the textbook. I just need to know how to apply those formulas. And that's what I am asking from you guys, because even if it was not an online course, in class I always had formula sheet. I never asked students to memorize anything, but I was always asking them to be able to apply the formulas that we learn in this course to the problems that we get. Am I clear?
Yep.
Yes.
Okay, then let me solve another. You see my blue screen, or do you see the problem?
Blue screen. Blue screen.
Now let me share. Maybe I don't share anything, just copy this problem into this blue screen. Okay, let me do 3-6. So in this problem we have IID sample y1. I have no idea why sometimes for is not behaving properly. I'm just kidding, but I just don't know why do I have to close Word every time to be able to write. So IID sample of n size, sample of size n. This is IID sample. You know what IID is, right? Independent, identically distributed. Identically distributed means that they come from the same. All of these yi, they come from the same population. That's why they are in that sense they are identical. And also independent means that y1 or any yi is not related to any other y's. Am I clear? If I'm not clear, just let me know. And we know that in this problem that these y's come from the population of mean mu of y. And then they are testing the hypothesis that this true. We don't know this true mean because I mean you can calculate mean of these y's, but that will give you y bar. Am I clear?
Yes.
All right. So, but this is not necessarily equal to true mu y true mean, right? You would be able to know this true mean if you had all of the yi's, right? So if you knew y1 and so on, all the way to y capital N, right? So then you know that n is small n is that part of it is less than this capital N. You never know all the observations, right? Okay, and they are testing the hypothesis that the true mean is 5. right? And the alternative here is that true mu is not 5. The alternative could be greater than 5, less than 5, but this will be like one side, right-sided, left-sided, but we don't have it here. We just have two-sided test, right? Hypothesis here. And you know how to test this, right? What is the first step is to calculate test statistic, right? Which would be what? Can you help me? This is something you need to know.
Is it y bar minus mu over standard deviation of y bar?
That is very good, but can you tell me here, can you specify this a little more?
Professor, is
Mu
it
is 5.
What?
Mu is 5.
No. So what is this mu?
Mu of y.
Can you be more specific, even more?
Population mean.
You are standardizing y bar, right?
is it population?
Yes.
Then what is this mu?
The population.
The true.
Guys, you are mu of y bar.
Yes.
Oh, mu. Okay.
Guys, I mean, you need to understand this in depth. So I am standardizing y bar. Why should I have mu of y here? Okay. But mu of y bar equals what?
5.
No? Mu of y.
All right.
How do we know this?
Because you said y bar is the best estimate for mu.
Mu of y? No, that's true. But I want you to tell me, how do we know this? What is the starting assumption to arrive at this? We derived this, right? We derived it in one of the previous classes. But what was the assumption necessary to derive this? Can you tell me? And then you can tell yourself that I understand this very well. The assumption was what? That yi is distributed IID normal with mean of mu of y and standard deviation sigma of y. All of yi has the same mu of y. That was the assumption. That was the starting point. And I said, this is in the heart of whatever we do in this course, right? So because of that, this equals y bar minus mu of y, right? Over sigma of y bar. But at the null, mu of y is equal to what? Mu 0, right? The hypothesized value. Which is 5 in this case, right? And because of that, you have that test statistic equals y bar minus 5 over square root of, sorry, sigma of y bar, but sigma of y bar is what? Sigma of I square root of n. Oh, we derived this as well before. So guys, you know, you have to understand everything here, right? So if you have any gaps in your minds, go back to the class slides, go back to the recordings and fill those gaps in. But again, if you have any questions, just let me know and we can go over this. Also, you can use office hours. I don't have office hours today, but I have office hours on Monday, so you can use those. None of this, you know, you don't need any of this in this problem, but I just reminded you. Based on test statistic, you can calculate what? P-value.
Standard of error.
No. you calculate test statistic using the standard error. But what standard error? That's like very vague, very ambiguous answer, but that's okay, that's fine. We just use standard error, or to be more specifically, estimated standard error by bar to calculate the test statistic. It is necessary to know before you calculate the statistic, otherwise you cannot do it. But once you know the test statistic, you can calculate p-value, right? And what we have is the following, that this is our normal distribution, and the problem says that the p-value that corresponds to this hypothesis is, what they say, 0.03. So that means that you calculated test statistic, right? I don't know the number, but this is some test statistic, right? And then you have minus test statistic here, right? Can you tell me what will be the p-value? Can you depict the p-value on this figure?
So is the p-value the area of the shaded region?
Where do I have the shaded region here? Which regions would you shade? Which regions would you shade?
Is it after the test statistic and before the negative test statistic?
That is absolutely right. So can you tell me if p-value is, I am telling you that p-value is 0.03. Then what do you have, what is this area?
Well, is each one going to be 0.015?
Do you mean that?
Yeah, because some of the areas give you the p-value, correct?
Yes, yes, because we have two-sided test. Guys, I really need you to be involved, right? So otherwise, we can take a long time to do just one problem. If you are involved, we can go on faster. So that's the p-value, right? Where would be 95% confidence interval here? Do you see 95% confidence interval here?
Don't you have to find the level of significance?
Very good. What is alpha?
5.05 or just,
You got that from here, right?
yeah.
And you can also depict the significance level in this figure, right?
You need the z value for, I think, for
That's,
that.
You should say z critical, right? Because test statistic is z value, but if you mean z critical, then yes, z critical corresponds to the significance level. Okay, but you know that the alpha divided by 2, which is like alpha over 2, which is in this case 0.05 divided by 2, will be on either sides. So 0.05 divided by 2, that's greater than 0.03 divided by 2. That means that minus z critical will be here at 5% significance level. And plus z critical will be here at 5% significance level. So where would be the significance level? It would be the area in yellow, right?
Yes.
And this yellow area will be 0.05 divided by 2. Same thing here. Can you tell me now, do you reject or accept the hypothesis, null hypothesis?
I think we reject, right?
Yes.
Because it doesn't include the 0.03 divided by 2.
Very good. Because of this, p-value is less than the significance level alpha. Can you now depict the 95% confidence interval? This figure? Guys, are you with me?
Can you repeat, please?
Can you depict 95% confidence interval in this figure?
Yes. Professor,
Yes.
can't you also just take the test statistics and then compare that to the Z critical value of 5%?
Yes, but do you have it here in this problem?
I'm not sure.
Okay. The question was, does 95% confidence interval contain mu equals 5? Now, having this figure, you can answer that question. Mu equals 5 corresponds to this test statistic, right?
Yes.
Is it inside or outside this
It's
Outside.
pink? Outside. So the answer is no, right?
Yes, no.
so you reject it.
No, you reject it, but the question, look at the question. You had a slightly different kind of question.
Okay, all right.
But you understand
No,
it,
it
right?
doesn't contain.
It doesn't contain. The answer is no. But why no? Because of all this explanation, right?
Yes.
That was part A or 1 or something, right? Part A, now part B. This was part A. What about part, does it contain mu equals 5, 6?
No.
No, because it doesn't, because 6 is greater than 5, right? 5 is already outside the confidence interval. How can 6 be inside? Do you agree with that?
Mhm.
Because the test statistic that corresponds to 6 will be even further. It's not in this pink shaded area.
Yes.
Okay, the answer is again no. That's how you do 3.6, and then let me do 3. Which one? Let's do 3.12 now. Let's see how it. I think we have enough time to do certain other stuff, but I also want to start chapter 4.
Professor, I just wanted to confirm. I think you told us that there are not going to be questions to prove something, right?
No.
So
This is not.
question is.
This is not about the proofs of proving something, right?
Okay.
If you did the homeworks, there are questions that ask you to derive certain stuff, to prove stuff. So, but this is not one of those questions. If you guys have any questions, just let me know, right? I'm not going very fast. I think I'm going pretty slowly, but that's okay.
Professor?
We have enough time. Yes.
So just really quickly, can you just quickly go over the steps that we have to do to answer a question like the previous one?
Yeah.
Just so you could just say it so it's in the recording.
It's in the recording.
Okay.
But it was like, no, I will answer your question. The thing is, that's okay. So I hope it's okay if I say that it's in the recording, but
That's fine.
I will still give you some hints. So when you have this kind of questions, right? First of all, what you need to realize is that this mu equals 5. The p-value for that is 0.0, so that's given in this problem. And 0.03 is inside 0.05. It's less than 0.05, which corresponds to the 5% significance level that corresponds to the 95% confidence interval. If anything is in the confidence level, if anything is in the confidence, the regions that the rejection regions that correspond to the confidence interval, that correspond to the significance level, that will be definitely outside of the confidence interval, right? So, clearly 0.03 p-value of 0.03 is less than 0.05 because of that. Whatever hypothesis you have that has this p-value 0.03, which is less than 0.05, the hypothesized value will be outside of the confidence interval. But that's really very vague, right? So that's really very vague. If I only told you that, I don't think you would be satisfied. But I did explain everything in steps. And if you want to understand in depth, then please listen to the recording once again, because all of this really provides you very clear in-depth knowledge for that question. Once you have this knowledge, then you really just you don't really need to do any derivations. There will be like no and no. So we have this table where we have certain information, right? And so we have I bar for men, for women, standard deviations, that's estimated standard deviations, right? Then we have the sample size, right? To investigate possible sex discrimination in a fur, a sample 100 men and 64 women with similar job descriptions is selected at random. A summary of the resulting monthly salaries are given below. Let's do number, not number, but let's part A. What do these data suggest about wage differences in the firm? If you look at this, right, then we really see that there is a difference, right? Because 3,100 is clearly larger than 2,900, right? Guys, are you with me? I just need you to confirm statement.
Yes.
Yes.
So then the thing is, okay, there is an absolute difference. But does it really mean that there is a difference? That's a question to you guys.
No.
Maybe no,
Why?
because the sample size is different as well.
I mean, that's not the answer to this question, but okay. Let me answer that question to you guys, for you. Okay, we do see absolute difference between the average salaries of men and women, but But this is based on this particular sample, right? In total of 164 individuals. Do you agree with me?
Yep.
Yes.
If you take another sample of the same number, of the same size, maybe of the same, but not necessarily the same people, would you necessarily have the same average salaries for men and women?
No.
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 Not necessarily, right? Okay. And if you even increase the sample size, so all kinds of stuff can you how many samples can you take?
A lot.
It just has to be less than the population, right?
The sample size will be less than population, that's true, but I asked a different question. How many samples can you take from the population?
As many as you want.
Money.
A lot
That's
of
exactly right. That's exactly not a lot of. A lot of is not the exact answer. The exact answer is as many as you want. You can just keep taking samples, right? But how many samples do you actually take?
1.
Why?
The best one?
Because it is costly, right? People are doing surveys, not people, but the things that the younger organizations are doing surveys, but they're doing surveys, and that's costly, right? So if you want to take a sample, that's very costly, and if you want to take it many times, that's costly, right? So then everything is related to cost. Are you guys with me?
Yes.
You just take one sample does not mean that you will not be able to take another sample or another samples. But you just take one, that's okay. But that's still gives you some ability to say something about the population parameters. And so because of that, the absolute difference does not really mean there's a difference in Y bars. Then, okay, so because of that, you don't really care about absolute difference, then what do you care about? Because absolute difference is not very meaningful. Do you understand that?
Yes.
So then what is it that you care about?
the true difference of the population.
That's true. But how do you, but yeah, that's very correct. But you don't know that, right? So you have to.
Is it the average difference?
Yeah, you'll be using Y bars to see that, but you care about what?
The mean population mean?
In statistical sense. Not the absolute difference. Okay. In the previous class, do you guys remember that I did a similar problem? That we had two states, students who did tests in both states, get averages from both states.
Yeah.
And we compared the means because we were interested if there's a difference in the true means in test scores. Right? This is a similar problem, right? Okay, are you guys with me?
Yep.
Yeah.
So okay, so you guys know how to do this, right? So what do this data suggest about wage difference in the firm? Directly looking at the table, we cannot say anything. Do they represent then statistically significant evidence that average wages of men and women are different? Okay, we have to test for that, right? So we have men and women. So they have mu of men. They have mu of women, right? When I say mu of men, I mean mu of what? Salary, right? Because, okay, hopefully this is clear. Mu of women, this is just a notation of the salary of women, true salary, the true mean of the salary of sellers of women. Those are just notations. So we're interested in, is there a difference between these? Right? Let's say there's no difference. I mean, let's hypothesize that there's no difference. If we reject this, then this means that there's a difference in statistical sense, and that is indicating the wage discrimination between men and women, right? Do you guys agree with me?
Yes.
Yes.
The alternative could be three types, but let's take let's take two-sided test, hypothesis test. It's not equal 0. You could test this man's salary is greater than the woman's salary, then it will be like this. Or that, if you are testing if men's salaries are less than women's salaries. But let's do the two-sided hypothesis like this. What is 0? What do we call this? So guys, up until now, am I clear?
Yes.
Yes.
We also call it null hypothesis or no?
We call this null hypothesis, and the alternative is denoted by HA. Sometimes it is denoted H1 by H1, but I think this is more. I think this is more appropriate because A stands for the alternative.
Okay.
Okay. So how do you test the hypothesis? You want to calculate test statistic, right? Test statistic will be what? Minus hypothesized value. Why is this? Because that's the best possible estimator of what? Guys, the true difference, that's right. So what will be in the denominator? Square root from the variance of what? But we showed in the previous class that this is the variance of y bar for men plus variance of y bar for women, but that's sigma men squared over whatever number of sample size for men, and plus sigma squared of women. I mean, this is actually s squared. This is a sample variance, sample s squared. And so just then plug in the numbers. What's the average salaries for men and women. That's 200. Women is men is 3,100 and women is 2,900. And you divide it by the standard deviations. Should be squared 200, 320, 100, not 100, 200. 200 squared, right? What was it? I just forgot. Sample size for men is 100 plus 320 squared over 64. I do this in Excel because that makes life much easier when using calculator. Equals 3,100 minus. Do you use my Excel?
No.
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 I'm just doing this. Close, divide, and I have to open the parentheses, then I have to open the parentheses again, then I have to end and open parentheses and close again. Here I have what? It was 200, right? What was the variance? What was the standard deviation? 200, right?
Squared over 100.
Okay.
And then it was 320 squared over 64.
And this is what we need. But then you have to take a square root of it, right?
Professor, you forgot to square 320, I think.
I forgot?
To square 320 in the equation.
Really? You're right. So you know why Excel is good? When I click it, it will automatically correct it as well. 0.30, let's do 32. But that's not the test statistic, right? Because the statistic will be this over z. But here I have to write down 3,100. Oh, is this right? No. Oh, I already did it, right? So there was no. I already did. I already did it, right?
But don't you have to square root the denominator first and then divide it?
Yeah. So this is incorrect. Let's make a correction. So I have to square root this whole thing, right? Cut. And then, okay, we will need one more parenthesis and then paste. Now, do you agree with this?
Yes.
Yep.
Yes.
4.47. Do you see my blue screen?
No.
Oh, yes.
Oh, yes.
This is your test statistic, right? What is the absolute value of this is the same, right? Because it's plus. What is the critical value at what significance level? Whatever. N is fine. But let's do like very, very high confidence. a level, let's say 99% confidence. Let's say we want to say something by being 99% confident whatever we say in it about it. So so I screwed up my English right now, but it's okay. Hopefully you understand. So I just wanted to say that whatever we will say, let's say by 99% confidence. Okay, then what is the critical value that corresponds to the 99% confidence, do you know? Okay, then that's what? At what level of significance? 1%. This is greater. So what do you conclude?
Reject.
Rejected.
So which means what? So there is a statistically significant difference between the average salaries of men and women. So that means that there is an evidence of statistical evidence of wage discrimination between men and women based on the sample we have here. Can we calculate p-value for this? What would be the p-value, guys? P-value will be 2 times probability z, capital C is less than minus 4.47. Do you agree with this?
Yes.
Yes.
And this is what?
Is it like 0? Close to 0?
It is not exactly 0, but it is very close to 0, right? Why?
Professor.
Because we know that z less than minus 2.99 is already very close to 0, and this, if this is the capital, then this will be even closer to 0, right? The p-value is 0. Go ahead and ask the question.
No, you answered it. Thank you.
Now let's do B. Do this data suggest that the firm is guilty of sex discrimination in its compensation policies? So how would you answer this question, guys? B.
That we are 99% confident that the firm is guilty of sex discrimination in its compensation.
Okay, that's if you are looking at this like entirely from the data point, how to say that, from the data tells you that. Oh, that's fine, that's right. But did you see the skills of these persons? Did you see the knowledge of these persons? Right? Maybe there is a difference because maybe men are more skilled. I'm not saying anything discriminatory here, but before you say anything, you have to make sure to exclude all the possibility, all the factors that might be contributing towards this difference.
Well, I was going to ask about the randomness of the samples. Like, what if they randomly really chose 64 women who hold a position of, let's say, secretary, and then 100 men who hold really high positions, but then it says that sample had similar job descriptions. So they are working similar job. Does that kind of go towards, like, can that support our answer if we believe that there could be discrimination since they do have similar job description?
I completely agree with your point. So they say these jobs are very similar. And the thing is, if these jobs are very similar, maybe what we think the data, we tested the hypothesis based on this data, we are 99% confident then that there's a difference between the salaries in statistical, average salaries in statistical sense. That's fact. for the fact we are based on the data, 99% confident that there is a statistically significant difference between men and women average salaries. That's for the fact based on this data. But then another question is this difference because the firm discriminates towards or against women, or is it because maybe men are relatively higher skilled in these particular jobs? For example, if you have like, I don't know, if you have a construction, if you I mean, I don't know, guys, please don't take any of my words, because I'm not discriminating against anyone by anything. I'm not discriminating anyone, but the thing is, the point is, before you say that there is a statistically significant statistically significant difference between the salaries, in addition, if you want to say this is because of this wage discrimination, you have to make sure that men and women have the very similar knowledge, education, everything. So there are other factors that could be reason why there is this difference.
So basically, we say we don't know because we don't have enough information to say.
We don't have enough information. We have enough information to say that based on this, we are 99% confident there is a difference in statistical sense, but we don't know why.
Okay.
That could be because there is discrimination against women, or maybe it could be that in this particular type of job, men are more skilled. That we don't know. We don't have enough information. Will we ever know that? Yes, we will have. We will learn something which will help us to control for the other factors that might be contributing towards this observed tested difference in the mean salaries. Am I clear?
Yep.
That's all, guys. I'm not solving any more problems. I think we did do quite a few problems that are, in fact, they are useful for the exam. So here, guys, looks like I forgot to say N of women, right? To write. But you hopefully understood it, right? Just did not say anything, but it's okay as long as you understand. Now chapter 4. Before I start, and we have less than 10 minutes, I just want to say the exam is on Wednesday, September 30. During the class time, we do not meet on this date. You just write the exam like you do the homeworks on the person. Sorry. 2:30. Let me write it here.
Professor, is it possible if we could start maybe 2:15 till 3:45, just have a little extra time, if we could come early?
I'm not sure if others can do that. So because people have different
I mean, if that's okay with everyone, obviously you have to get a consensus.
Yeah, that's cool.
Yeah.
Yes, guys. Maybe I have responses from a few of you, but the thing is, I'm not sure if I have to be fair towards everyone, right? So I prefer to do it during the class time. That was the reason why I rescheduled it, right? So from Sunday to Wednesday, because I've received emails that they cannot do it on Sunday. That's completely understandable because we all have our stuff. So let's do it during the class time, and you all will be on the same boat.
Professor?
Yes?
So we're going to be having class on Tuesday, right?
Let me say something in that as well. So Monday, next week, which is, I think, 28, right? Follows, sorry, not Monday, but Tuesday follows Monday, right?
Yes.
9/29 follows Monday. And we will have class on Tuesday. The same time. We will not have any more review.
Okay.
On Tuesday, I will have office hour. You can ask questions about the midterm or anything, or any other questions during this office hour, okay? On Tuesday, we will explain chapter 4. Please attend classes. And the slides are already on the CUNY Blackboard. I think I don't have any more time. I will just finish today's class, and I wish you guys good day and good weekend.
Thank you, Professor.
Thank you, Professor. Have a good day.
Professor, the exam is at Wednesday, right?
Thank you, Professor.
No problem. Yes, the exam is on Wednesday.
Okay, thank you.
No worries.
Thank you. Have a good one. Bye.
You too, guys. So I will stop recording and then I will leave. I wish you all a good weekend, and if you have any questions, you can always reach out.
Professor, do you know the exercises at the end of each chapter? Where do you find the answers for that? In the textbook.
The thing is, I solve a lot of them, and also the homeworks also are based on those.
Yeah, but does would the textbook provide them, or we have to compute them on our own?
You have to compute them. As I said, the homeworks are basically a reflection of the end of chapter exercises.
Yep, I understand. Thank you. Have a good day.
You too, guys.